Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2123, indicates a high voltage condition in the APP Accelerator Pedal Position sensor A circuit. This sensor is crucial for relaying the position of the accelerator pedal to the engine control module, ECM, which controls engine performance and throttle position. The APP sensor is typically located near the accelerator pedal assembly. When the sensor sends a voltage signal above the normal operating range, it triggers the P2123 code. It's essential to address this issue promptly to maintain optimal vehicle performance and prevent further electrical issues in the system. Recording freeze frame data and onboard snapshots prior to troubleshooting helps understand the vehicle's condition during the fault occurrence. This information is crucial for our diagnostics and repair process. The APP sensor plays a pivotal role in engine performance by detecting the angle of the accelerator pedal and transmitting this information to the engine control module, ECM. This sensor is generally located within the pedal assembly or very close to it, ensuring that it accurately reflects pedal position. A high voltage condition, as indicated by DTC P2123, suggests that the voltage signal from this sensor is exceeding 4.9 volts, which is not within the expected range. This abnormal signal can lead to erratic throttle control, impacting vehicle acceleration and efficiency. Moreover, it's essential to understand that the APP sensor is integral to the drive-by-wire system, which controls the engine's throttle electronically. If malfunctioning, it can cause delayed or unexpected vehicle responses, posing safety risks. Several factors could lead to the P2123 error code, each requiring careful inspection. First, a faulty APP sensor is a primary suspect, as internal failures can cause voltage readings to skyrocket. The wiring and connectors to the sensor and the engine control module, ECM, are also critical. Poor connections or damaged wires can create resistance or short circuits, affecting sensor performance. Additionally, issues may arise from outdated PCM software, which could be incompatible with the current system conditions, resulting in faulty readings. One common pitfall is not thoroughly checking these connections and wiring prior to assuming the sensor needs replacement. Ensuring all possibilities are accounted for is crucial in the troubleshooting process. When encountering the P2123 DTC, several symptoms may manifest, signaling a problem with the APP sensor. One of the main symptoms is erratic throttle response, where the vehicle may hesitate or accelerate unexpectedly. Drivers may also notice reduced acceleration, which can significantly affect driving experience and safety. In addition, the check engine light will typically illuminate, providing a visual cue that an issue needs addressing. Such symptoms can indicate that the engine is not receiving accurate data regarding the accelerator pedal position. Left unresolved, these issues can lead to further complications in vehicle performance and safety. Understanding how these signals present in real-world driving is crucial for diagnosing specific problems within the system. The first troubleshooting step involves turning the ignition switch to the on position, ensuring electrical power is supplied to the vehicle systems. Next, utilize the Honda Diagnostic System, HDS, to check the APP sensor parameters. It is essential to observe the voltage readings. Ideally, APP sensor A should read more than 4.9 volts under current conditions. If the readings are as expected, it confirms that the current conditions replicate the failure symptom, allowing us to proceed to the next troubleshooting step. If the readings are inconsistent or not within the expected range, this could indicate an intermittent fault. In such cases, examining wiring connections or looking for loose terminals is advised to ensure reliable signal transmission. For the second troubleshooting step, Begin by turning the ignition switch to the lock position to safely disconnect electrical components. Next, the APP sensor's 6P connector must be disconnected. This action isolates the sensor from the circuit for accurate measurement. After disconnection, turn the ignition back to the on position to check the voltage between two specific test points. You will measure between test point 1, app sensor connector number 4, brown wire, and test point 2, app sensor connector number 5, light blue wire. The expected reading is approximately 5.0 volts. If this condition is met, it's a strong indicator that the APP sensor requires replacement, since it's likely malfunctioning. Should the voltage not meet this threshold, it directs our diagnostic efforts to the wiring and circuits upstream. The third step is initiated after confirming no issues with the APP sensor voltage. Again, start by turning the ignition switch to the lock position. Once ensured, utilize the HDS to jump the SCS, service check signal line, which helps in isolating circuits for diagnosis. Disconnecting the PCM, Powertrain Control Module, connector A is essential. It's crucial to connect terminals A and B with a jumper wire, proceeding with the process. Here, terminal A connects the APP sensor number 5, light blue wire, to body ground, which will aid in measuring electrical continuity. After jumping, check continuity between test points 1 and 2, which will help confirm if the SG4 line is intact. If continuity exists, replace the PCM if it is running outdated software. If continuity fails, identify and correct any open circuit issues in the SG4 wire, ultimately ensuring a full circuit connection. After completing all necessary repairs or replacements regarding DTC P2123, a final verification steps in to confirm everything works correctly. Start by turning the ignition switch to the lock position, safely reconnecting all previously disconnected connectors. Ensuring all connections are snug and secure is crucial before powering the system back on. Once reconnected, turn the ignition to the on position to prepare for resetting the Powertrain Control Module, PCM, utilizing Honda Diagnostics System, HDS. Following the reset, undertake the PCM idle learn procedure to recalibrate the system for optimal vehicle performance. Finally, check with the HDS for any new pending or confirmed DTCs, ensuring the initial issue has been completely resolved. This thorough verification process safeguards against any lingering faults. To prevent future occurrences of the P2123 DTC, it's vital to engage in consistent preventive maintenance. Regularly inspecting all connectors linked to the APP sensor and PCM not only helps in identifying potential issues early, but also encourages longevity for these crucial components. Keeping the PCM software updated is equally important, as updates often come with refinements that enhance compatibility with the car's system. Additionally, monitoring throttle response can help detect irregularities before they escalate into major issues. Pay attention to how the vehicle performs during acceleration. Any hesitance or unexpected behavior can indicate early warning signals. Initiating these preventive measures consistently can significantly reduce the likelihood of facing similar issues in the future. In conclusion, understanding the intricacies surrounding DTC P2123 is key to effective diagnosis and repair. This code highlights a high-voltage problem in the APP sensor circuit that demands immediate attention to maintain vehicle operations. Being thorough in following each outlined troubleshooting step allows for accurate identification of the fault, whether it be a faulty APP sensor, wiring issues, or software discrepancies within the PCM. Furthermore, implementing an ongoing preventive maintenance routine is essential in reducing the risk of future DTCs and ensuring optimal vehicle performance. By recognizing the symptoms early, addressing potential faults, and adopting best practices in maintenance, vehicle owners can enjoy a safer and more reliable driving experience. Please like and subscribe to the channel. See you next time.